Assalamualaikum, good day. In this video, I would like to discuss on how to find the value of a constant k from a given continuous random variable from a given probability density function, okay, as the piecewise in the question. And next we will sketch the probability density function, and afterwards we will find the probabilities given by the question. So let's get started. Now, to find the value of constant k inside this piecewise, as I circle inside there, so we just need to find the probability, the area under the graph, okay, over the domain, okay, from minus infinity until infinity. But since it's a piecewise, okay, with a different set of interval, so we have to split the integration. So the integration start from minus infinity until 0, okay. So there's one function, and then 0 until 2, okay, in terms of x, plus something from 2 until 3 in terms of x, and last but not least 3 until infinity for dx. Okay, so for the first integration, the function is 0 because it is here otherwise. Okay, so the first one and the last one is 0. Okay, for the second integration, it lies from 0 to 2, which is this one. So we are taking this function, which is kx plus 1, while the integration from 2 to 3 is this function, so 2k. Correct. So as we know from previous videos, these two are 0. We can just leave them be. So we see k's all over inside the integration. We can take it out because clearly from the question it says k is constant. So put k outside to 0, x plus 1 dx plus k to correct, 3 to 2 dx. Now, so integration of x square over 2 plus x with 2 and 0 as the upper and lower limit respectively, and k to x 3 2. Okay, so this integration, the integration of fx over minus infinity to infinity must equal to 1. So just put 1 there, and then we substitute the values here. So 4 square pula salah, 4 over 2 plus 2 minus 0 plus 0, okay, and then plus k 2 3 6 minus 4. Okay, so that is 4k plus 2k. Therefore k is 1 over 6. So we can rewrite the small f there. Okay, so fx is x over 6 plus 1 over 6 when 0 x 2, okay, 2 0 include. Okay, next is 1 over 6 multiplied by 2, so 2k. 1 over 6 is 2 over 6. 2 over 6, 1 is 3. Okay, so 1/3 when 2 until 3, and it is 0 otherwise. Okay, so this is the we rewrite the function with the known value of k. Now, the next part is sketching the probability density function. Okay. Now, this one is how to sketch it better is to represent the piecewise function in a number line as I did in front of you, and then we put, first thing first, we have to put the values 0, 2 and 3. We cut them into 4 different intervals. Okay, so and then we made a we made a number line, correct, is the interval. No, we represent the interval. I'm sorry. So we represent this interval on the number line. So you see 0, circle on top of 0 must be then circle. The circle on top of 2 must be empty circle. And then we join this points. We join the circle, sorry. So this is, and afterwards we write the function. So this is the function that belongs to this interval. So x over 6 plus 1 over 6. Okay, and next, this interval we are going to represent them. So it's a dense circle on top of 2 and empty circle on top of 3. Okay, and I think it's included, isn't it? Oh, my bad. It's included. Sorry. So it's a dense circle here. Okay, dense circle as well. While the function being 1 over 3. So the function here is 1 over 3. So after that, we find the coordinate of the circles that we have here. So 0 we substitute into this function. Okay, we substitute into this function. We get 0, we get 1 over 6. Okay, same goes to value of 2. Okay, when we substitute 2 over 6. 2 over 6 plus 1 over 6 is 3 over 6, 1 over 2, half. 1 over 2. Okay, padam all. Okay, now let's proceed to the next circle, this one. Okay, so this one very easy, 1 over 3. This one 2 over 3, because this is just y equals 1 over 3. Okay, so nothing to calculate here. Okay, so we already get the coordinates of all the circles. Okay, then next we sketch them over here. So 0, 1 over 6 is somewhere here. This is 1 over 6. So it's a dense circle. So I made one dense circle here. Okay, and then we point to half. So this is 2. Okay, and then this is half. Okay, this is half. And then you see this point is this one. Okay, while this one, the open circle, is this one. Okay, so let's proceed. Let's join them, join the circles with a straight line. Why it is a straight line? Because this line represent this line. This line represent this. And this is a linear equation. Okay, next we're going to plot this dense circle. Okay, so 2 1/3. 2 1/3 is between 1/6 and 1 1/2. My mistake. And half. So the circle should be here and it's dense. Okay, and then on top of 3 I have the same height of a 10 circle on top of 3, and then we join them, and then this one I extend the dash line and I label it with 1/3. So this is the sketching of the function of small f. Okay, next, find 1.5, the probability from 1.5 to 2.5. Now, the probability of getting x greater than 1.5 less than 2.5, okay, we can use this sketching to guide us, yeah, or rather you can use this if you want, almost the same thing anyways. Okay, now where 1.5, it's somewhere here, 1.5. So we want the area, we want the probability, sorry, we want to get the area from 1.5 until 2.5. Sorry, from 2.5 here. So as you can see here, there are two equations involved. Okay. The one that the shaded area that I shade just now involves two different functions. So we have to split the integration. So for the first integration lies from 1.5 until 2. Okay, so the upper limit is 2, and the function involved is the first function, you see here, which is x over 6 plus 1/6 in terms of x, plus the integration from 2, you see, from 2 until 2.5. 2.5, the function involved is 1/3. Okay, so let's integrate it. X squared over 12 plus x over 6 plus x over 3. Okay, let's substitute the values. So 4/12 plus 2/6, 1.5 square over 12 plus 1/5/6 plus 2.5/3 minus 2.3. Okay, so let's get the values. Okay, is divides by 12 plus over 6, so 2/3, 1.5, 7/16 plus 2.5 by 3, okay, 5/6 minus 2/3, so 2/3 is missing, so 5/6 minus 7/16 minus 7/16, 5/6 minus 7/16, because these two become 0, right? Okay, so that's just what's left, so 19/48. Yes. Okay, so we've done with that. Let's look at the last part of the question, finding the probability of x greater than 1.8. Okay, in this For this one, okay, now since from this you see, from this number line that we made to represent our piecewise better, okay, so the question wants 1.8, which is somewhere here, 1.8 and above, and above means all the way on up here until at the end of the domain. So as you can see here, there are 1 and 2 different intervals involved. So rather than doing this, it is better and smarter if we get 1 minus by the probability of x less than 1.8. Okay. Actually, it doesn't hurt you to do this. Okay, you can integrate it from 1.8 until 2. Correct limit, okay, 2. Okay, the 2 with a function dx, okay, plus the integration from 2 until 3 from a different function in terms of x. You can do this one as well, okay, but we want to get a shorter calculation. Okay, so let's proceed with that. So x less than 1.8 means that 1.8 is the upper limit. So what is the lower limit? The lower limit, or in fact the lowest limit, is 0. Okay, 0. 0. Correct. 0. Okay, so z is we have to integrate from 0 until 1.8, and the function involved is the one lies from 0 to 2, which is x over 6 plus 1 over 6. So 1 minus integrate x squared over 12 plus x over 6, 0.80, 1.8. Let me calculate with my calculator. 12 tambah over 6, so 1.8. 1 minus, that's weird, why I get this value. That's annoying. Oh, I'm sorry, there's some confusion with my calculator. So the value is 1 minus, when we substitute all this, we get 57 over 100 minus 0. 0, correct. So 1 minus is 43 over 100. So that is the probability for the last question. Thank you for your time and attention. Assalamualaikum. Good day.